Hi everyone, so today we are focusing on the inverse of a function written as f with a superscript of minus 1 of x. That stands for f inverse of x. So before we get into what the inverse represents, let's take a look back at a regular function, right? So we have the function f of x equals 2x plus 3, and the given domain is x is a member of 1, 2, 3, and 4. So we have 4 members in the domain, and we're just going to go back to our mapping diagrams just to refresh ourselves on what a function represents. So our function f of x is 2x plus 3, and when 1 is the member in the domain, that becomes 2 by 1 for 2x. 2 by 1 is 2, 2 plus 3, 5. So 1 is mapped onto 5 in our range. When x is 2, that becomes 2 by 2, 4. 4 plus 3, 7. Similarly, when x is 3, 2 by 3, 6. Add 3 is 9. And when x is 4, 4 by 2, 8. 8 add 3, 11. So our function f of x equals 2x plus 3 takes us from our domain to our range. And today we're going to look at the inverse function. Now the inverse function is the opposite of our regular function because it takes you in the opposite direction. It takes you from the range back to the domain. So it's a function, it's written as an expression, and it's going to take you from these values here, 5, 7, 9, and 11, back to the values in the domain that they're associated with, 1, 2, 3, and 4. So there's a method to finding the inverse of any function, and we're going to look at that method now, and then we're going to find the inverse of this given function, 2x plus 3. So there are 4 steps to finding the inverse of a function. So the function we're going to find the inverse of is f of x equals to 2x plus 3. Step 1, rewrite f of x as y. So we're going to do step 1 now, and where we have f of x, we're going to replace it with the letter y. So this becomes y is equal to 2x plus 3. Step 2 now says to interchange. Interchange y and x. That means everywhere we have the letter y, we're going to rewrite it as x, and everywhere we have the letter x, we're going to rewrite it as y. So this becomes no longer y, but x is equal to not 2x, but 2y plus 3. So we've done step 1, we've done step 2. Step 3 now, make y the subject of the formula. This means we want to change this until it becomes y is equal to some expression. So we want to get y alone on one side of the equal sign. In order to do this, I'm going to take what I have written on the right, which is 2y plus 3. I'm putting that on the left, and what I have on the left, I'm putting that on the right. Just so we'll end up with y alone on the left-hand side. Didn't change anything. Now, on the left, we have 2y plus 3. We want to get y alone, so let's get rid of the plus 3 first by carrying that on the other side. Now, we know when we carry a term on the other side, the sign will change. So it's not going to be plus 3 anymore. We're going to write it after the x. It's going to be x subtract 3. Now we have 2y is equal to x subtract 3. But we want to get 1y. The only way to get 1y from 2y is to divide by 2. And we have an equal sign here. What you do on one side of equal sign, you have to do on the other. So if we divide it by 2 on the left, we must divide by 2 on the right. Now the left becomes 2y on 2. The 2's cancel out. And finally, we get y is equal to x minus 3 all over 2. We have completed step 3. Now, the final step is simply to replace y with f inverse of x. So instead of y, it's f inverse of x equals to x minus 3 on 2. And this is the expression for the inverse function. Let's see if it works, if it takes us from the range back to the domain. So our range values were, and we're just going to look up on top again, they were 5, 7, 9, and 11. 5, 7, 9, and 11. And our inverse function now is f inverse of x is equal to x minus 3 all over 2. Let's see if we get back 1, 2, 3, and 4. When we put 5 into this function here, it becomes 5 subtract 3, which is 2. 2 all over 2 is 1. When we put 7 into the function, it becomes 7 take away 3, which is 4. 4 on 2 is